we will learn the various steps which are used to find the current and the voltage in the combination of resistor problem. First of all, find the equivalent resistance of the circuit. Second is, after finding the equivalent resistor, find the overall current in the equivalent circuit. Third is, find the voltage drop across the series resistor from the equivalent circuit. And fourth one is the then find the current in the individual resistor. Now let's solve some example. Let voltage V be 10 volts. Here let it be R1, R2. This is R3, R4, R5, and this resistor is R2. Let the value of R1 and R2 be when R2 would be equal to 2 ohms, R3 equal to R4 equal to R5, which will be equal to 3 ohms, and R6 equal to 6 ohms. Now we have to find current and voltage drop across each resistor in each resistor. Now see how to find it. First step is find the equivalent resistance of the circuit. Equivalent resistance. First see this connection is parallel. This is also parallel. So we have equivalent resistor of 1 and 2 is equal to 1 by R1 plus 1 by R2. R1 and R2 is 2 ohm. So if you substitute the value, it will become 1 by 1. So R equivalent of 1 and 2 is 1 ohm. Now this parallel connection, the R equivalent of 3, 4 and 5. It is equal to 1 upon R3 plus 1 upon R4 plus 1 upon R5. Now it will become 1 upon 3 plus 1 upon 3 plus 1 upon 3 equal to 3 upon 3 equal to 1 by 1. So R equivalent of 3, 4, 5 is 1 ohm. Now R6 is 6 ohm. Now this circuit will be reduced to this. So we have here 10 ohm. This will be equal to 1 ohm. This one will be equal to 1 ohm. And this is 6 ohm. Let's give a note a name. A, B, C, and this is D. Now this is a series connection. This is a series connection. Therefore, its equivalent is the equivalent resistor of the circuit is 1 plus 1 plus 6 equal to 8 ohms. So this will be reduced to 8 ohms. voltage is 10. Now let I be the current flowing. Now the next step is find the overall current. So from Ohm's law we know that V equal to IR. Therefore I equal to V by R total. Now V is 10 and R is 8 ohm. So it becomes 5 by 4 ampere. This is the total current flowing in this circuit. I equal to 5 by 4 amperes. Now is find the voltage drop across the series resistance of the circuit. What do you mean by series resistance? Refer to this series. Now this is in a series. Let the node be V, A, B, C and D. So the voltage to drop, let voltage drop be VA across AB, VBC across BC and VCD across CD. So, so 10 volt is equal to VAB plus VBC plus VCD. Now what is VAC? VAB. Now let's find the voltage drop across VAB. We know that VAB will be equal to I into resistance in the node AB. In the node AB we have one node. So it will be equal to 5 by 4 into 1 is equal to 5 by 4 volt. Now similarly VBC. VBC will be 1 into 5 by 4 equal to 5 by 4 volt and VCD will be equal to I is 5 by 4 and resistance is 6 ohm, 6. It will become 30 by 4 volt. Now, how do we check that this answer is right? The sum of this potential difference must be equal to 10 volt. So let's check. So what is the total? Total is 5 by 4 plus 5 by 4 plus 30 by 4. It will become 40 by 4 equal to 10 volt. So our potential differences has been calculated. Now, now consider this node AB. AB. Here we have two resistors of 2 ohm and 2 ohm. Now we know that sum of current entering a junction is equal to sum of current leaving a junction. And the potential difference across AB is same. So the potential of V1 will be equal to potential of V2. This will be equal to potential across AB. So we know that VAB is 5 by 4. So V1 is equal to V2 is equal to 5 by 4 volt. Now how to calculate current? Current I equal to V1 by R1 and current I2 will be V2 by R3. Now V1 is 5 by 4, R1 is 2 ohm. So it will be 5 by 8 ampere. Similarly, I2 is also equal to 5 by 4 into 2 is equal to 5 by 8 ampere. So we have found current I1 and I2. Now similarly in between the node B and C, this is B, we have three parallel connection. Each one is 3 ohm. Now let the current be I3, I4 and I5. So in a parallel connection, potential is same. So we have V3 equal to V4 equal to V5 will be equal to VBC. Now VBC is 5 by 4 volt. So it is equal to 5 by 4 volt. Now so I3 will be V3 by R3. It will be equal to 5 by 4 into 3. So it will become 5 by 12 ampere. Similarly, I4 will be V4 by R4 equal to 5 by 12 ampere, and I5 will be equal to V5 by R5. This will also be equal to 5 by 12 ampere. Now the between the nodes C and D, we have a series resistor which is equal to 6 ohm. So the current will be I6 equal to V6 by R6. Now V6 equal to VCD. So V6 is equal to VCD, and VCD is 30 by 4 and R6 is 6 ohm. So this becomes 5 by 4 ampere. So we have found all the voltage and all the current.